Here are solutions to homework set number 5 for ECE 111, Intro to ECE. This homework set looks at renewable energy. This is kind of a follow-on to last week's homework, where we showed that CO2 levels are going up, global temperatures are going up, the ice is melting, gloom and doom. Is there anything we can do? Well, actually, yeah, there is. We can move away from fossil fuels with solar, wind as other ones, and this is just looking at. Let's analyze solar panels, let's analyze wind turbines, and see if they're cost effective. As engineers, we have access to data. We're really good at analyzing numbers, or analyzing data. Let's see for ourselves, do they make sense? Now, if you go on eBay, you can buy solar panel kits. This, for example, is from EcoWorthy. It's a 15 kilowatt solar panel kit with I believe a 10 kilowatt hour battery inverter. All for $84.69 on sale. Is that profitable? How much energy would you get if you actually installed this on your roof? How long would it take to pay for itself? Well, the first step is we need data. Well, data is readily available. If you go on the 111 website on Bison Academy, and Bison Academy, the semi-official website for the electrical engineering department at NDSU, here's different courses. Here's 111. Scroll on down. This is the link to ENDON. ENDON is from agriculture at NDSU. It's got stations all across North Dakota. For example, click on Rugby. Here's the weather station in Rugby, North Dakota. It measures sunlight, wind speed, wind direction, rainfall, soil moisture, stuff like that. Click on weather data hourly. You can pick your favorite site in North Dakota. For example, if you like Rugby, North Dakota, Rugby. Here's all the data that's being collected. The one we want for the first part is, where is it? Solar radiation average. On the second part, it'll be wind speed average. So for solar radiation average, it's pick a 4-week time span, whatever you want. I could do like March 1st through March 28th. There's a 4-week time span, get table. This gives the time, the hour, and the wind speed in English units, or sunlight in English units. Switch over to metric. You'll find in engineering, metric is way, 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 way easier. Do everything in metric. Export CVS file. And here's the file. Open it. And here's your data. It's the last column. And apparently I don't have Excel on this computer. Well, copy into Matlab. So the units are megajoules per square meter. Copy that in Matlab. I say megajoules is data, or actually didn't put that in here. I said data is start of matrix, paste, just copy and paste, and there it is. The second column, well, the data that I copied, the second column is megajoules. That's the last column, wherever it was, of the data that I had. Pull that in. There's 672 data points, so that's the hours, collected on an hourly basis, then plot it. So what this is showing is the solar radiation in Carrington, North Dakota during March 2025. You see sunrise, sunset, the different days, cloudy day, sunny day. There's the raw data. Problem 2. Convert the data to units that I want. I want kilowatts. I currently have megajoules per square meter. To convert that, a trick in engineering is watch the units. I want to get the units into kilowatt hours, actually. So I've got megajoules per square meters. To get rid of the meters, I've got 78 panels. Each panel is 0.89 square meter. This cancels with the square meters. To convert megajoules to kilowatt hours, there's 1 million joules in 1 megajoule. So the megajoules cancel. There are 3,600 joules in 1 watt hour. Joules cancel. There are 1,000 watt-hours, and a kilowatt-hour. So I'm left with units of kilowatt-hours. And the efficiency is 21%. Only 21% of the solar energy gets converted to electricity. So the conversion is 4.0495. So what I want to do is take the megajoules, multiply by 4.0495, and that'll convert me to kilowatt-hours. So if I add them all up, that's the total energy over 28 days. Add them all up times 4, that's the total energy in kilowatt-hours. So this is how many kilowatt-hours I produce over that 28-day period. And this trick is pretty common. To convert units, get everything to cancel, and you wind up usually with the right formula. That's the trick in engineering. Watch the units. If the units don't match up, you got it wrong. If the units do match up, you probably did it right. Problem 3. Okay, I know how many kilowatt-hours. How much is that worth? Well, to do that, I multiply kilowatt-hours times 11 cents per kilowatt-hour. I get $154. The number of pounds of coal, it takes 1.78 pounds of North Dakota lignite to produce 1 kilowatt-hour. So these panels would offset 2,400 pounds of coal over that 28 days. That's a lot of coal for one house. Think about how many houses there are in North Dakota. It adds up. Problem 4. How long does it take for these panels to pay for themselves? Well, you can buy the panels for $86.49 on eBay, available today. I get $154 every 28 days. Converting that to a year, I get $2,000 per year, assuming I use all the energy I produce. It'll take about 4.3 years for the panels to pay for themselves. This says, as of today, this is actually a pretty good deal. If you can put solar panels on your house, you're going to make money. Ignores the installation cost. But if you install it yourself, it's a pretty good deal. Kind of a word of advice. If you're ever going to buy a house, look at the roof. You're going to want a south-facing roof. You want to put these solar panels on the south-facing roof. That's where you get the most energy. You may not want to put them in today, but eventually you will. So houses with south-facing roofs should be going at a premium. They let you put in solar panels. The other thing to note is this is without subsidies. If there were government subsidies, it's even better. But with no subsidies whatsoever, just buying it off eBay, paying out of your own pocket, it's a good deal. It's a good investment. And only going to get better. Solar prices actually dropped by half over the last 2 years. Like most electronics, prices are dropping. It's getting more and more affordable every year. Already, solar is affordable. Let's look at wind energy. Same idea. Go to end on, pull in average wind speed, paste it into Matlab. In this case, the second column was my data. I pulled in 2 columns for some reason. I've got 28 days worth of data, 672 hours. That's the size of the data. Discount 1 to 62, 1 to 672 for the x-axis. Plot it, and this is what the wind looked like in Carrington, North Dakota during March 2025. Okay, given that data, let's convert it to energy. If you go to Vesta, they've got power curves. For example, this would be the power curve for a Vesta 120 2.2 megawatt wind turbine. Here's the wind speed at 0 to 3 miles an hour. It doesn't generate any energy. It's not blowing hard enough for the wind to turn the turbine. As the wind increases, I get more and more power, and it caps out at 2,200 kilowatts. Come up with a function in Matlab where I pass it wind speed, it returns kilowatts. Now, one way to do that is to split it into 3 regions. Between 0 and 3, I output the number 0. Above 13, I output the number 2,200. And in the middle, I'll do a curve fit that matches this data. One way to do a curve fit is kind of by trial and error. A cubic actually works out pretty well. Here's the x values, here's the data. Do a cubic curve fit. Those are my coefficients. Weightings on x cubed, x squared, x and 1. I'll then spin through the data set. I pass it a bunch of data, and I'll return 0 if the wind speed at that data point was less than 3, I'll do my 2200 if the wind speed is bigger than 13, and my curve fit if it was between 3 and 13. Now, anytime you're at a function, you want to check it. If the wind speed goes from 0 to 15 meters per second, check the power curve. The solid red line is the power curve. The dotted is my function. Seems to match up pretty well. Now that I'm convinced it works, let's take the data, multiply by 1.8, because I want to go from 2 meters above the ground, where the data is collected, to 120 meters above the ground. From Wikipedia, that scaling is about 1.8. Find the kilowatts at each data point and plot it. Here's the energy that wind turbine would be producing on an hour-by-hour basis. Sometimes the wind blows, sometimes it doesn't. Let's do some analysis. The total energy I would produce over those 28 hours is add it all up. That's the command sum in Matlab. I would produce 536,000 kilowatt hours over those 28 days. At 11 cents a kilowatt hour, that's worth $59,000. The pounds of coal I would offset is take kilowatt hours times 1.78. Again, it takes 1.78 pounds of North Dakota lignite to produce 1 kilowatt hour. That's from the Milton Young power plant in North Dakota. I would offset 900,000 pounds of coal. Big numbers. And the last problem is, how long does it take the wind turbine to pay for itself? So this is the money I generate every 28 days. In 1 year, I would generate $769,000. It would take 3.78 years for this wind turbine to pay for itself. In business, anything that pays for itself in less than 7 years is a good deal. This is a really good deal. This is part of the reason you're seeing so many wind turbines going up in Minnesota, Iowa, South Dakota, North Dakota. They are cost effective. And this is without government subsidies. This is standing on their own. Going back to homework set number 4, when we mentioned that CO2 levels are going up, temperatures are going up, ice is melting, can we do anything? Yeah, we can. And we can save money while doing it. There's wind, solar, batteries, geothermal, nuclear. Wind and solar are actually the two cheapest way to produce electricity today, without subsidies. With subsidies, they're even better. So if you're looking at what to do to save the world, electrical computer engineering is a really good major. If you're not looking at changing the world, saving the world, it's still a really good major. I like saying that we build toys, but toys for a purpose. Our graduates build defibrillators, pacemakers, flight controllers, stuff like that. Stuff that makes people's lives better. And it might save the planet too. So that's homework set number 5 for ECE 111.